This conference will now be recorded.
Okay, so in this session, let us understand method overriding. There is a concept of method overriding. Okay, we understand method overloading already. Yeah? So method overloading is a concept of defining multiple methods with the same name by differentiating the number of arguments that we pass to the method or the type of the arguments that we pass to the method, right? So for example, I have a method m1 and m1 has a parameter integer x. This is one method. So for example, this is one method. And I have another method, same method name. So if you look at the method name with parameters, okay. So here m1 method with single parameter. Now I have two parameters, int x comma into y. This is a separate method. Now both the methods are different methods, but if you look at the method signatures are different, but method name is same. Okay, when we talk about method signature, what is that? So this is a terminology. Method signature is a terminology. Okay, where we call the method name along with the parameters. Along with the parameters, we call that as method signature. So method signature, for method overloading, method signature must be different. Okay, for method overloading, method signature must be different. Must be different. Must be different. For what? For method overloading. Method signature in the sense method name along with the parameters, we call it as method signature. If you look at this method signature and this method signature, both are different. So and method name is same. So we can say these two methods are overloaded methods. These two methods are overloaded methods. And the method name can be with the different parameters also. If the number of parameters are same, then the type could be different. So float f. So how many parameters I have in this particular method definition? I have only one parameter. How many parameters I have in this method definition? Only one. So number of arguments are same for that method and for this method. This, if you compare these two methods, but the method signature is different in terms of what the type. So when you wanted to say two methods are overloaded methods, said to be overloaded methods, then so the method signature must be different in terms of what? Different in terms of number of arguments. Okay, number of arguments. Meaning the number of arguments could be different. Okay, or type of arguments, or type of arguments, and also order of the arguments. Even that also you can say for example, I have a method m2. Okay, m2 with the two parameters, integer x, float f. Integer x, float f, or say for example string. Okay, so integer and float. Now I have another method m2, but here I have taken the string as a first parameter, but integer as a second parameter. So these two methods are also overloaded methods. Compiler accepts without having any compilation issues, because compiler will understand, oh, this method is different and this method is different, because it can differentiate by looking at the order of the arguments. While calling this method m2, if you are calling this method, okay, if you are calling the m2 method using 10 comma hello, then it will understand. So this method call should be bind with this particular method definition based on the type of arguments and the order of arguments. It will map that. And if first suppose I am passing first parameter as a string parameter and the second parameter as an integer parameter. Then by looking at, so compiler can bind this method call with this method definition. Method call with method definition. So the compiler is smart enough by looking at the difference of the parameters in terms of arguments, number of arguments, or type of arguments, or order of arguments. And then you can say, so that is what method overloading. Okay, and method overloading happens within the same class. Okay, method overloading happens within the same class in Java, within the same class. When you define a class, so all these methods you define within the same class, right? So, and this resolution, so resolution in the sense, we can say method resolution. We can say method resolution. What does it mean? Method resolution meaning, so to understand, our compiler should identify, okay, this method call is for this particular method, or this method call is for this particular method. So on what basis method method calls are going to resolve, that's what method resolution. So method resolution, it happens, okay, by compiler during the compilation time. Compiler during the compilation time. During the compilation time, method resolution happens by the compiler during the compilation time. So what does it mean? So this means that is, okay, compiler is smart enough. Compiler is smart to identify and bind the method calls with the method definition. Meaning what? So this method, okay, when you call this, which method has to be executed? M2 of integer and string. So this should execute. When you call this, which method should execute? This method should execute. Right? So that is what. So that understanding and that resolution can be done by compiler itself during the compilation. So that is what this is known as. It's not at a runtime, right? It's not a dynamic, it's a static time, it's a compilation time. So overloading is a concept of what? So we can also say that overloading, okay, uh, is a static polymorphism. We can say it is a static polymorphism. Overloading is a concept of static polymorphism, or is known as overloading is known as a static polymorphism. Okay, so now coming to the point, so what is the polymorphism? So this is one of the key features of object-oriented programming. What are the four pillars of the object-oriented programming concept? So we know that encapsulation, okay, encapsulation, data hiding, right, polymorphism, and inheritance, right? So that's what. So we discussed this already, which is known as polymorphism. The method overloading is said to be a polymorphism. What type of polymorphism? It is static polymorphism. Okay, if you interpret this polymorphism term, polymorphism, okay, this is poly means many and morphism means more forms. Okay, many forms. The same guy can behave in different ways, depends on the context, right? So here the same method name M2. Here it is taking two parameters. Here it is also taking two parameters but different in order. And here it is taking a single parameter but different type. So here also taking a single parameter, different type. The same guy, the same method behaves in different ways. And of course, this guy has different implementation, right? Some logic, whatever logic here. This logic is different and this logic is different. Of course, obviously, right? That's why I'm writing different method. The logics are different in the sense the implementations are different. Implementation in the sense you can say behavior. Method implementation is nothing but what? Behavior. And behavior of that particular entity class. Okay, so that is what. So behavior. So the same guy can behave in different ways. Okay, in different ways. This is a generic term, generic sentence. But when you look at the technical terms, in technical terms, okay, the same method have different forms. Same method have different forms. Do you understand now? The polymorphism means, okay, polymorphism is a concept of, okay, having different implementations, okay, having different implementations for the same method, different behavior for the same method. Okay, same method have different forms. That is what, or different behavior or implementation. Okay, understand? Also, we can say also, static polymorphism or method overloading is known as, okay, enhancing the existing functionality or behavior. Okay, say for example, I have a add logic. For example, I have a add logic index comma into y. For example, this. So now I wanted to I wanted to implement the add logic with the three parameters, with three values. So I can say index comma into y comma into z. So what I'm doing here is I'm enhancing this. What I'm doing here, enhancing the functionality, the behavior. This behavior adds add two numbers. But here I'm adding three numbers. I'm just putting in simple words, okay, simple things to understand it better. Okay, so method overloading is known as what? Enhancing the existing function. Okay, method overloading is said to be enhancing the existing functionality, and method overloading happens within the same class. Method resolution can be done by compiler during the compilation time. So we can say this is a static polymorphism. And polymorphism, when you say polymorphism, the same guy behave in different ways, meaning that the same method have different implementations with the different method signatures. Method signature is nothing but method name with parameters, right? Okay, so it is like this is nothing but enhancing the existing functionality. Okay, we'll come back to this again. Okay, let's understand method overriding now. Okay, method overriding. One second, give me a second. All right. And so this yeah, these are the four object-oriented oops concepts. Like, out of it, we understand encapsulation already. We understand about inheritance. We are understanding polymorphism. Right. So data heading also we discussed a bit, but yeah, I will give more details about this. Right. So if you come to here for polymorphism, and it's two types. Okay. Static polymorphism, dynamic polymorphism. Okay. Dynamic polymorphism. Static polymorphism and dynamic polymorphism. And static polymorphism is nothing but what? Method overloading. You can, so we can give an example of what? Static polymorphism. So it's clear now. Static polymorphism. Polymorphism is in two types, static and dynamic. Okay, static polymorphism is what method of overload. It achieves using method of overloading concept. Okay, so dynamic polymorphism is going to achieve using the inheritance concept. Okay, using inheritance concept. Method of overriding. So now, if you understand, come to method of overriding. Okay, so this is a concept of like based on the name you can understand. Based on the name itself, you can understand. Overriding meaning that what, but I whatever the existing functionality that I have, I don't want to go with that. I wanted to write or define my own implementation. Okay, so I have a logic here in my method. Okay, I have some logic here. Okay, say for example, okay, I have system out println of okay simple hello. Okay, I don't want this. I don't want this implementation. I wanted to print, hey, how are you doing? Okay, I wanted to go with this was I don't want to go with hello. Instead, I wanted to do what? Hey, how are you doing? I wanted to do this. Okay, so now in this case, if you wanted to override this particular implementation by this particular implementation, so you have to ensure both the methods are same in terms of signature. Meaning that method of overriding, okay, method of overriding, okay, method of overriding to define this, okay, to implement this, we must have, okay, we must have, or you can say method signature must be same, and for overloading method signature must be different. That's a basic difference of method of overloading and method of overriding. Method signature must be same in method of overriding. Method signature must be different in case of method of overload. Okay, that is the point number one. And point number two, the method signature must be same. And when you wanted to override, when you are going to override, something like you should be having this method, uh, which is uh, already coming to me, like which is already there, which is already available. That I don't want. Meaning what? So that's what you have to understand a bit about inheritance again. Okay, so I have a class over here, that is what parent class. I have a parent class and my parent class has m1 method m1. Now I have a child class. Okay, I have a child class. This is what my child class, and this child class is extended by parent. This child class is extended by parent. And here, my child class is having one method. What is that? Say M2 method. Say M2 method. So parent class has one method and child class has M2. So this is a like when you look at this, when you look at uh, class logic, parent class logic, you would see M1 method. If you look at the classes, child class logic, you would see M2 method. But this is a child class of parent earner. When two classes are related using like inheritance concept, obviously whatever the properties I have in my parent, they will be inherited into my child class or not. Of course, they will be inherited into my child classes. Meaning that so I'll be having a copy of my parent here or not. That is what whatever the available methods in parent, they will be they are also available to what my child class. Meaning that they inherited into child. This is a this like physically you don't see when you look at your class C child class definition, you don't see this method m1 physically, but logically, so internally it has that. Okay, logically you can say Okay, child class has what? A method M1, because child class is inherited from parent class, and the M1 extended by parent class, and M1 method is inherited from the parent. Okay, that is what now. So in this case, you can say like what is the implementation of M1 over whatever implementation I have here in M1 of parent that comes to here or not logically. So this M1 and this logic both are same or not. This is available. Now, if I create object for my child, if I create object for my child, say C equal to C is equal to new C. What I'm doing? I'm just creating a new object. I'm creating just what? New object for what? Child. Now, once I got the child object, I could be able to call my methods or not. So C dot what I can call the M1 method as well as I can call M2 method. Yes or no? Because M2 method is available in my child class, whereas M1 method is inherited from the parent and available to the child class. When I say C dot M1, so this particular logic is going to execute by default. Yes or no? So that logic, I don't want to go with that particular logic. I wanted to override this logic, whatever logic I have in my parent that I don't want boss. I wanted to override that. But that is where, so we got this concept, overriding concept, method of overriding concept. Hope you understand. Okay, now let's see. Let's go with the examples of this. Let me take a simple class, new. Let me create a new class, new class. Let me say base class. Okay, base. I have a base class here. Let me create one more file. Okay, let me create one more class. Base class, subclass. Okay, base or a derived class. Okay, derived or a child, whatever it is. And this derived class must be extended by what? Base. Derived class extended by base. So you know this, right? Now, in my base class, okay, I have a method what M1 method. This what my method M1. So method return type is compulsory for methods in Java. Okay, just like function you can define. The return type must be declared. If your method is not returning anything, then the return type should be what? Void. Okay. So what I'm doing is I'll simply say base. Okay. So this now I'll go to child class, derived class, which is derived class. So my derived class doesn't have anything, right? Just let me write main method, and here I'm creating object for my derived. Okay, derived d equal to new derived. So I'm just creating what object, derived object. Now d dot what is the method m1 is available or not? That's what the point here. So d dot m1 is available or not? So D is what derived class. So directly, if you look at physically, if you look at this code, does this code has M1 method defined in this class? No, it's not. But still, I'm able to access it, and this is nothing but it goes to the base class and it accesses that M1 from there. So meaning that this logic is going to execute. Yes or no? This logic is going to execute. Now, I wanted to, if I wanted to execute, or if I am fine with going with the base implementation, then okay. So it executes the base class one. But now the scenario is I don't want to go with the logic whatever I have in my inherited method. Okay, I wanted to write my own logic. I wanted to write my own logic. What is the method M1? So M1 method. Signature must be same. So this M1 and the base M1 signature must be different. Correct? So if you look at here, okay, so here M1 I'm defining my method. Okay, so I am derived. Now if you run this, so which will be executing now? So while calling it, when you are calling a method, so it goes based on the reference. What is the reference here? D. D is of type what? Derived. So it looks, okay, runtime JVM looks for this particular M1 method in the derived class. So does the derived class has that method implemented or not? Yes, it is implemented. So it will execute. If this is not implemented, then it goes to base class and it looks for the method in the base class. If it is available, it will execute. That's all. That's how it works. Okay, first always JVM looks for the method in the reference type. The reference type is what? Derived. So in the derived class, it looks for the M1 method. If it is not available, then only it goes to the parent and it will okay. Excuse me. Then only it will what? Execute the parent. Now see, what is the output? I am derived because I have overridden that. Okay, I have overridden this. Okay, so this is what overriding method. This is what overriding method. Okay, overriding method, and this is what overridden method. Okay, so now if you look at to implement this overriding concept, we need two classes or not. That's what parent and child. So overloading happens within the same class, whereas overriding happens. Okay, overriding happens in the base and child classes. Okay, base and derived classes. We already familiar with the terminology, right? We can say derived, or we can say sub, or we can say child. Okay, or you can say base or super or parent. Right? So overriding concept can be implemented using this base and derived classes, parent child classes. Method signature must be same. Method signature must be same in case of method overriding. Method signature must be same in case of overriding. All right, all right. Now we understand 2 points. Okay. So on what basis? Uh, this method resolution happens based on the underlying object, right? That's what important point here. When JVM trying to execute this particular method, it looks for the method M1, but from where it has to execute, that is what it looks for this reference D. Now what is the type of it? So derived. So in this particular class, does it have that method? Then it will execute. Understand? So that is what. So based on the type or you can say object. Yeah, keep this point in this way. Okay. So the method call happens in case of overriding. Okay, method or method resolution. Can't say method resolution. You can say method calls. Okay. Method calls happens based on the runtime object. 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 So here object is what? New. If you use new keyword, then you can say that is what your object. Derived D equal to new derived. So reference type is reference is D and object is what? This is what object. Okay, this is what object. So if you see okay, so object. So object will create and it will be there part of memory. Okay, and if you imagine this is a memory area, so remember by default all the objects creates in the heap memory. Okay, in the heap memory I created an object. What is that? That object referred by a reference type of D. Okay, so this is my derived object, and where the reference will be stored, that will store in a different memory. Okay, we call it as a stack memory. We call it as what? Stack memory. We'll try to discuss this memory things also in coming sessions. Okay, stack. So here our reference will be stored. What is the reference here? In this case, D. D is what? Our reference. Okay, And object is what? This is what our object, actual object. So this is actual derived class object created. Okay, and this guy refers this fellow. Okay, the D refers this particular object. Any questions so far? Any questions? So it has M1 method, of course. Now when I say D dot M1, this is going to call this particular guy M1. D dot M1. Understand? Now I have another object, I have another class, but I don't have any object for that. Okay. Now for suppose, let me create object of that. So for example, what is that base? Okay, base B is equal to new base class. Okay. When I create this, what is my object here? Base class object. In this case, my object is what? I have another object. What is that object? Base class object. Okay, so actual base object. What is that reference? So B. I have referred this object using B. So further, if I wanted to access any properties of this particular object, I will use this reference. I will use this particular reference B. So here, if you look at this guy, okay, this guy, okay, B, actual object, and this guy is also has a method M1. This guy is also have method M1 because that is because both the classes are related, parent child. Whatever I have in my parent class, that will be available to what my child. Right now, if I call B dot M1, B dot M1. So what method will be called? Like what will be the output here? So here I have implementations in two objects in the two classes, right? In the derived class, I have implementation of what? So this is having the implementation. I am derived, right? This is what the logic I have. Print statement of this. Okay. Yes or no? My logic is just derived. And here, what is the logic I have? I'm just having this. Okay, this is the logic. Now, if you see here, okay, what is the object here? New derived. So, if the object is a derived object, then when you call M1 method, the derived class object, the derived class method is going to exist. If the object is base class, then when you call M1 method, the base class method is going to exist. So, meaning that, so this prints what? Base, and this will print what? Derived. Yes or no? Now see that. This run it and see. I am derived and base. I'm derived and base. I'm derived and base. This is what prints. And this will print base. Hope this is clear. Any confusions so far? Okay. Perfect. Okay. Cool. Then I will now I will play with this now. Okay. So always we can assign child object to the parent class reference. If there is a point, there is a rule base is equal to new derived. Okay, derived. So here, if you see, I can still call M1 method or not. Now both are different. So in the above case, in this case, reference type is what? Derived. Object is what? Derived. In this case, reference type is what? Base. And object is what? Base. But here the object is derived, but reference type is what? Base. I'm calling base. Okay. On top of it, B is already I have taken the variables. Variable names cannot be duplicated. It cannot allow within the same scope. Okay. So let me modify this B to B1. Now, what is the output here? Is it going to print based on the object or based on the reference type in this case? Any guesses? That's what. So that's what the point here you have to understand. Okay, now so prints reference based, because reference is what, b1. Okay, so b1 is what, base. So prints base, that's what you mean to say. Okay, let me run this and show you. So what is the output? Is it printing base? I'm derived, and base again I'm derived, but what you said is base. That is what the point here I'm saying. When you are accessing like this, when there is a confusion, okay, you have to look for the object, but not the reference. But not the reference. What is the object here? Derived class. So when you call this M1 method, what is the runtime object? So what, and in the runtime object, what data I have, that is going to execute. Okay, in my runtime object, if this is not available, then it will go to the parent and it will get that execute. But it has implemented, right, the derivatives. So it is going to print what? Print the derived class stuff. I'm derived. Only thing 20 sutra, you can say whatever. Blindly you can remember always in this kind of like relation. When you create an object for child class and assign to base class, then simply you can say always blindly you can say the method calls are going to happen based on the object. Okay, so that's what the point here. The method resolution, method calls method calls happens using the depending on the runtime runtime object, because it's execution time. So at compilation time it cannot be like it, compiler doesn't know, it cannot bind with the method call with the method definition, because compiler is not known what is the runtime object at the compilation time. That happens only at runtime. So that is what. Okay, so method calls happens, method call binding. Okay, method call binding happens depending on the runtime object. Okay, runtime object during the execution, during the runtime. By whom? By JVM. Method call binding happens depending on the runtime object during the runtime by JVM. JVM decides that the binding, and of course JVM is only going to execute that. Right. So that's the important note here. So that is the reason we call this as a dynamic polymorphism. Okay, so dynamic means runtime. So this is known as, this concept is implementation of what? So method overriding is a concept of, okay, dynamic polymorphism. Method overriding is a concept of dynamic polymorphism. Method overloading, you can say it's an example, it's a concept of what? Overloading. Okay, method overloading and method overriding. Method overloading and method overriding. We have seen both. All right, now we understand about the methods. We understand about the methods. What if, or what how it works with respect to variables? Okay, so of course we'll do have variables, right? And they also get inherited, right? So say for example, I have a variable x value is 100. I have a x value and I have that value. Let me print the value here. Let me print the value. Okay. And in the derived, okay. Let me have the same x here also, integer x equal to 200. Let me print this here. All right. So anyhow, no differences here, right? So this is, I'm derived, so it's going to access this 200 here, right? And it's going to print a base, so it's going to access 100. I'm derived, it's going to access 200. Is that how it's going to work or not? Okay, so see the output. So I am derived 200, base 100, I'm derived 200. So derived class, it is accessing the derived property. In the base class, it is accessing base property. Now, these here in this case, it is accessing from the method. So it is part of method. So it depends on the method. Whether it is derived or parent. Based on that, it accesses that particular object data. Now, I wanted to access them directly using the reference, not part of the method. So meaning that, so I have a D, parent D dot M1. I'm calling M1 method D dot, sorry, D dot X, D dot X. So let me say D dot X. I'm printing X value here. Also, I wanted to print B1 dot X. Also, I wanted to print B dot X. Okay, now can you guess what are the outputs that we can see here? D dot X. Okay, as it is like reference is D, so is it going to print 200? Okay, and here B dot X base, right? So is it going to print 100? Is also base, so 100. Is this the output that you expect? Or B1 is the object is derived, so I'm going to get 200. So 100 or 200. What is the output here? What is my output here? 100 or 200. Let's execute. 200 we get. Why? Because the object is derived object, and it depends on the runtime object. Okay. So see here, run and see the output. 200, 100, and 100. Okay, so here this is not a different thing. That's what I was I'm taking this example here. Okay, always method resolution. Always, just you can remember blindly. Okay, always method resolution, method calls, method bindings happens by JVM depends on the runtime object. Okay, runtime object. Whereas the members or data members, or you can say data members are nothing but variables or properties. Okay, are still okay, depends on the reference type. Still depends on the reference type. Only the method bindings only, because we got a overriding concept. Okay, so we that has to be resolved by JVM while calling it. But the variables are not like that, right? There is no concept of overriding for variables, right? So that's what it's always depends on the reference type. It's always depends on the reference type. Right. So you understand it? You have any questions around this? Okay, let's take slowly one by one. Okay, so I want you to understand clearly. And tomorrow we'll see a few more points around this overriding concepts only. So tomorrow also we'll continue with the overriding. So there are certain rules that we need to follow whenever we are overriding a method. Okay, with respect to the method signature, we understand that, right? Method signature must be same. What about the return types? What about the exceptions if it is throwing? So certain kind of things we'll look at tomorrow. Okay, and along with the member access modifiers, access specifiers. Okay, that is it. Let's stop it here for today. Let me know if you have any questions. While overriding, so always like methods are going to calls based on the object, and the variables are going to depend on the reference type. Okay, if your reference and object both are same, then no confusion. Okay, and that's what. So just try to differentiating method overloading and method overriding. Method overriding happens in the parent and child classes. Method overloading happens within the same class. Method overloading is enhancing the existing functionality, okay, whereas method overriding is like concept of rewriting the logic. Okay, overriding is a concept of redefining the method, redefining the behavior, right? Whereas overloading is enhancing the existing functionality. Okay, method call happens, binding happens at runtime. In case of method overriding, for method overloading, it happens at the compilation time by compiler. That's what known as static polymorphism, and method overriding is known as dynamic polymorphism. Okay, all right. So when you are having this object and reference types, depends on the underlying object, the method calls are going to happen. Depends on the reference type, the variables are going to exist. If we summarize the things whatever we discussed, that's all. Simple. Okay, right. We understand about polymorphism. It's two ways: static polymorphism and dynamic polymorphism. The static polymorphism, like its implementation of what? With the overloading. Overloading, we understand about the overloading, and dynamic polymorphism is what? Overriding. Method overriding. So method overloading, enhancing the existing functionality. Method overriding is redefining the functionality. All right, so let's continue tomorrow with the access modifiers and the rules for method over. I'll send out this. Just go through it and let me know if you have any questions by tomorrow.